Moving on here, we're looking at some word problems that are going to involve trig functions. So we have here, let's look at example number 1. Frank gets on a Ferris wheel at the bottom. So he's getting on the Ferris wheel at the bottom. Okay, obviously you're not getting on the Ferris wheel at the top. And it's a time equals 0. The Ferris wheel has a radius of 13, but its center is 15 meters off the ground. In total, it takes, I think, 32 seconds, to complete one rotation. And we want to sketch. Okay. So, we're going to need to fill this out. For almost all of these word problems, time is on the x-axis. So this is where time is. And on a Ferris wheel, it's going to take us 32 seconds to do a rotation. And our height will have to go here. So how high are we on this Ferris wheel? So you're going to start down here somewhere, and then you're going to be at the very top. Then you're going to be back at the bottom again. So we're going to have this. We should have this sort of trig sine cosine function. We are going to need to start labeling this. So I'm going to label this in 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, maybe let's label it up to 10. You can label all of them if you want. Now it does say that we get on at the bottom. So automatically we are sitting, when we first get on this Ferris wheel, we are already, the minimum height we can be is going to be 2 meters or feet? I don't know. 2 meters. The radius of this thing is 13. So if you go up by 13, you're going to be at 10, 12, 14, right here, 15. Which should make sense that we're at the bottom, we are at 2 meters, and then halfway up, we'll be at 15 because we go up 13 meters, which is the radius, but also it tells you the center is at 15. So that makes sense here. That's where you're at the center, and then you're going to have to tack on, I guess, another 13 to this. So I guess you're going to be at 28. So right here is going to be, here we are at 28. So, I mean, it also should make sense looking at all of this. It doesn't matter how you think about this. If you start at 2 meters and you know your 13 meters is your radius, therefore your diameter would be 26. So if your diameter is 26 and you start at 2, well, then you need to end at 28, which is what you see here. Okay, so we should, what is a sketch? Okay, well, we know a couple of things already. We know our D was at 15, which we've already done. And we know that our A, which is our amplitude here, is our radius, which is 13. And I'm assuming at time zeros, you start at the bottom. Now, you don't start here on the ground, you start at the bottom of the ride. So when time is 0, you start at the bottom of the ride. And 32 seconds later, you are now going to be also back at the bottom. So if we follow the same thing here, this would be 2, 4, 6, 8. And so we can go up this way. We're going to get to, I'll put time over here, 32. So 8. So I'll just do here, well, I don't know, 10. And then 12, 14, 16, 18, 20. 22, 24, 26, 28, 30. So 32, here we go. 32, we're back at the bottom. So that's good to know. So 32, we are back at the bottom. This ride now ends and you're back at 2 meters off the ground. So halfway in between, you are going to be at the top of the ride. So we're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, obviously it's going to be 16 here. So halfway would be 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is at 16. I said 16 because I knew this was 32 seconds. So obviously halfway in the middle would be 16. And if everything's worth 2, I can just count 8. So at 16, your 16 seconds, you're going to be at the top of the ride. It takes 32 seconds to end it. So you'd be at the top at 16. So midway, you're going to be between 16 and 0 would be 8. So there's 8. You're going to be in the middle. You're going to be at 15. And then halfway here, 1, 2, 3, 4. you're going to be at 16 plus 8 is 24. And then that would be another 8 to 32. So that works. Now, I think it says include 5 points. So I've done that here. But sometimes it's helpful if you look down. Sometimes they ask, like, how long will it take for Frank to be 20 meters off the ground for the 4th time? And well, you think, okay, well, he's going to be 20 meters off the ground heading up, and then he's going to be 20 meters off the ground heading down, but then he's going to do it again and then head back down. So it's going to have at least 2 rotations, which is why I might keep going here. So 1, 2, 3, 4. That's at 40. So you're at the bottom here, so now you'll be at the middle. And then 1, 2, 3, 4. So you're at 48. We'll be here at the top. And then 1, 2, 3, 4. That would be 56. We'll be back here at the center. And then 1, 2, 3, 4. 64, you're back here at the bottom. Which takes 32 seconds to do 1 rotation, double that to get to the end. So this is what this thing looks like. And I try to draw as much curves here as I can, because we are going to be estimating some things. Okay. And this would go like that if you can go back in time, which you can't do. So that is drawing at least 1 period. I've drawn 2 cycles, 2 periods. And it says derive a sine and cosine equation. Okay. One of the things we need is our 13 and our 15. But what else we need is our b value. Now that we don't know, but we do know that the period, how long does it take to do 1 cycle? We know it takes 32 seconds. So to find our b, that's 2 pi over your period, which is 2 pi over our period's 32, which is pi over 16. That is our b, pi over 16. So we have our a, we have our b, we have our d, and of course our c always depends on how we shift things. So this is a really good way to kind of go back and just reinforce what we learned last time. Now I'm going to do one of each, like a positive and a negative of each. And I know that we're going to have our a value is 13, so it's going to be 13 and negative 13. 13 and negative 13, so I'm going to do a positive and a negative. And I'll do maybe cosine here first, and then I'll do sine. Now we can go for our b value. By the way, if you're having difficulty with this in any way, you might want to go back and rewatch some of the other video. But our b value goes here, which is pi over 16, I believe. And then there's some room for some x stuff. And then we have a d, and so our d value was the center, which is 15. So we'll go plus 15. So we're coming up with, I know it says only 2, but I'm coming up with 4, a positive and a negative, just to reinforce what we learned last time. Okay, so now we need to come up with the positive cosine. See how much we've shifted. I'm going to put x here for all of these. So let's do positive cos. So cos starts at the top and heads down. So cosine would normally start here and head down. And so how much does it need to move so that it overlaps? So it needs to move to here. How much does this need to move over to the right? I need to move to the right. I don't know what number this is. 16. I need to move to the right 16. So I'm going to go, because it's right on minus, and I'm going to put 16. So if I move it 16 to the right, then my cosine equation would line up perfectly with this, which is what I'm trying to do. I'm trying to generate an equation that looks exactly like this. Now let's do a negative cos, a flip cos. Cosine normally starts at the top. Now we're starting at the bottom. And what do you know? It already lines up. So I need to do nothing. So you can put a plus 0 or a minus 0, or you could just leave this part completely blank if you wanted to. Next, let's do a positive sine. So sine starts in the middle and heads up. Go right here and heads up. How much does it need to move for it to line up? So it needs to move over to here. Because right now this doesn't look like my drawing at all, but if I moved it over to the right, I'm going to 8. If I moved it 8 over to the right here, then it would line up perfectly with this drawing. So that's what I want to do. I move it over 8 to the right. So I'll minus, that means right, and then 8. And then lastly, negative sign, that starts in the middle and heads down. It's the flip a sign. So I need to move it all the way to here, because then that would look like this, which matches up. So I need to move it to the right. It looks like 24. If I move it to the right 24, it would line up with my drawing. So all of these equations now line up with my drawing. So that's question B. Question C, how far above ground is Frank after 10 seconds? So we're just estimating here. So here's 10. And you can look at my drawing if you want my PDF. It looks a little bit nicer. So at 10 seconds, I am, I don't know, somewhere right there. So this is 22. So you're somewhere between 20 and 22. So maybe you're at approximately 21 meters. Now I do have a drawing of this that I did here. So at 10 seconds, I actually put it into the equation, and I find out I chose an equation and I plugged in 10, and you got, look, 20. But if you look at the drawing, if you did a really nice drawing like this one is, you go up to 10 to here and over, that gets you 16, 18, so 15, 16, 17, 18, gives you around 19. So this drawing, 10 seconds gives you around 19. My drawing gives me here somewhere around 21. Turns out the answer is actually 20. So anything is good. It's based on your drawing. So everyone will have a slightly different answer depending on what the drawing is. All right, so how long will it take Frank to be 20 meters off the ground for the 4th time? So let's erase this. And then you're off the ground, how many meters did it say? 20. So 15, 16, 18, 20. Okay, so this is 20. I just erased that. Wow. So here's the first time. That's on your way up. And then you're at 20 meters on your way down. Then you go for a second time, 20 meters on your way up. And then on your way down, it looks like here, if that's 56, you're looking at around 54. So it takes around approximately 54 seconds if we want to go around for the 4th time. Now I'm just curious to know, what does that look like over here? 19 to 20, so there's 20, 20, 20, 20. So it looks like just shy of 54, so maybe 53, 52. But, and we looked at the graph, so approximately 54, 53. So that's exactly how I did it there. So my drawing looks like, roughly around 53, but something around there. So that's it. There's 2 more word problems to do. And I love these questions because they can incorporate in there everything we learned last unit in making these equations. And then there's some predicting questions here at the end. Take a look at the answer key for some better drawings.